Have you ever looked at something and thought, wait, that can't be right? Get ready to question everything you see, because today we're diving into the top 10 visual illusions that prove your brain is constantly lying to you. Let's start with a classic, the Muller liar illusion. You see two lines. One has arrowheads pointing inwards, the other has them pointing outwards. Which line is longer? Your brain screams it's the one with the outward pointing arrows, right? Well, sorry to break it to you, but they are exactly the same length. Get a ruler and check if you don't believe me. This happens because our brains use past experiences with corners and perspective to judge size. The outward arrows look like the far corner of a room, making it seem farther away and therefore bigger. The inward arrows look like the near corner of a building, making it seem smaller. Your brain is trying to be helpful, but it's getting tricked by simple lines. Next up, number 9, the Kanisa triangle. Look at this image. Do you see a bright white triangle sitting on top of another triangle and 3 black circles? Of course you do. But here's the twist. That white triangle doesn't actually exist. There are no lines drawing its shape. Your brain is creating it out of thin air. It sees the Pac-Man-like shapes and the V-notches and assumes there must be something covering them up. So it helpfully fills in the blanks, creating a shape that isn't there. This shows how our brains love to find patterns and create complete objects, even when they're missing information. Coming in at number 8 is the Ebbinghaus illusion. You see 2 orange circles, each surrounded by other circles. One is surrounded by large gray circles, the other by small gray circles. Which orange circle is bigger? Most people will say the one surrounded by the small circles. But you've probably guessed the punchline by now. They are identical in size. This illusion works because our brain judges an object's size based on its context. Compared to the large circles, the orange circle looks small. Compared to the small circles, it looks huge. It's all about relative size. Your brain isn't seeing the circle for what it is, but for what it's next to. Let's move on to number 7. Checker shadow illusion. This one is a mind-bender. Look at this checkerboard with a cylinder casting a shadow over it. I want you to look at square A and square B. One is a dark square and one is a light square, right? They look completely different. Square A is dark gray and square B is light gray. Well, brace yourselves. Square A and square B are the exact same shade of gray. I know, it sounds impossible. Your brain automatically compensates for the shadow. It knows that a square in a shadow should be darker, so it lightens square B in your perception to make sense of the scene. It's a powerful demonstration of how our brain's knowledge about the world, like how shadows work, directly changes what we see. At number 6, we have the Fraser spiral illusion. Take a look at this image. It looks like a perfect spiral, coiling inwards forever, but it's not a spiral at all. It's actually a series of concentric circles, one inside the other. The illusion is created by the tilted black and white segments that make up the lines. These small tilted segments trick your brain into thinking it's following a continuous, spiraling path. If you try to trace one of the circles with your finger, you'll see that you always end up back where you started, proving it's a circle, not a spiral. Your brain is taking a shortcut, and in this case, the shortcut leads it down the wrong path. Halfway through our list, at number 5, is the Ames room. This one is famous from movies and science museums. In photos or when viewed from a specific peephole, a person walking from one corner of the room to the other seems to grow or shrink dramatically. It looks like a normal rectangular room, but it's a clever trick. The room is actually trapezoidal. The floor is sloped, and one corner is much farther away from the viewer than the other. But because we assume the room is normal and rectangular, our brain misinterprets the size of the people inside. It concludes that the person in the far corner must be tiny and the person in the near corner must be a giant. It's a powerful example of how our assumptions about the world can completely override reality. Now for number 4, the Ponzo illusion. Picture 2 horizontal lines placed between 2 converging lines, like a railroad track heading into the distance. Which horizontal line is longer, the top one or the bottom one? The top one looks significantly longer, and by now you know the drill. They are the same length. This is another illusion that plays on our brain's use of linear perspective. The converging lines give us the impression of depth, making us think the top line is farther away. Our brain has a rule. If 2 objects have the same size on our retina, but one seems farther away, the farther one must be bigger in reality, so it scales up the top line, creating the illusion. At number 3, we have motion after effect. also known as the waterfall illusion. You've probably experienced this. Stare at the center of a waterfall for about 30 to 60 seconds, and then look away at the stationary rocks beside it. What happens? The rocks will appear to be moving upwards. It's a bizarre feeling. This happens because the neurons in your brain that detect downward motion get tired or fatigued. When you look away, the neurons that detect upward motion are still fresh and fire more strongly than the tired-out downward motion neurons. This imbalance creates the perception of upward movement where there is none. You can try this at home by staring at any continuous motion, like a spinning spiral. Our runner-up at number 2 is the incredible spinning dancer. This is a silhouette of a woman spinning. The question is, which way is she spinning? Clockwise or counterclockwise? Some of you will see her spinning one way, and others will see the opposite. What's even crazier is that you might be able to consciously switch the direction she spins. How is this possible? The silhouette is ambiguous. There are no depth cues like shading or perspective, so your brain has to make a guess. It fills in the missing information, and depending on whether it assumes her left foot or right foot is forward, you'll perceive a different direction of spin. It shows how our perception is an active process of construction, not just a passive recording of the world. And finally, the number one visual illusion that proves your brain is lying to you is the blind spot. That's right, you have a blind spot in each of your eyes, and you probably never even notice it. It's the point where the optic nerve connects to the retina, and there are no photoreceptor cells there. So why don't you see a black hole in your vision all the time? Because your brain is a master of deception. It takes information from the surrounding area and literally fills in the gap. It makes an educated guess about what should be in your blind spot and paints it in, so your visual field appears seamless and complete. It's a constant, effortless illusion that's happening right now as you watch this. To find it, close your left eye and stare at a fixed point. Hold up your right thumb to the side and slowly move it outwards. At a certain point, the top of your thumb will just disappear, filled in by the background. Your brain is actively lying to you every second of every day just to make the world look stable. So there you have it. From filling in blind spots to changing the size of objects, your brain is constantly editing and interpreting reality. It's not a perfect window to the world, but a powerful prediction machine doing its best to make sense of everything. What you see isn't always what you get. Thanks for watching. Which illusion blew your mind the most? Let me know in the comments below. And if you enjoyed questioning your own reality, don't forget to like this video and subscribe for more mind-bending content. See you next time.